This is Notes 9.4. We're going to talk about inscribed angles in circles. So by the time you're done with this lesson, you should know how to find the measures of inscribed angles and how to find the measure of angles of inscribed polygons. The first theorem has to do with circles with an inscribed circle, or an inscribed angle in a circle, and an intercepted arc. So you have to know what those are first. So let's go over that. So an inscribed angle is one that has a vertex on the circle, and then it intercepts an arc, meaning that the two sides of the angle go out to the circle, and then they intercept that circle, and the arc inside that is called the intercepted arc. So you have to know those two definitions to do this. Okay, and it turns out also that the measure of angle 1 is half as big as the measure of the arc. So think about this. The measure of the arc is the same as the measure of the central angle. The central angle for this arc is the one that has a vertex on the center. The inscribed one, so that's inscribed, has a vertex on the circle, and it's half as big as that central angle, or half as big as that arc. So for the example here, find the measure of angle x. The measure of angle x is, here's the intercepted arc, here's the inscribed angle. So 86 divided by 2 is 43. And then it's degrees. And then the measure of arc xy. Arc xy is intercepted by this angle right here. So this is the inscribed angle. And then the measure of this arc is 104 degrees. So this is 43 degrees and this is 104 degrees. The next theorem has to do with two inscribed angles on one intercepted arc. Since both of those inscribed angles intercept arc AD, each of those angles is half of the measure of AD, so both of them are congruent to each other. So we can try this on this next example. It says find the measure of angle R. The measure of angle R is this inscribed angle, and it intercepts the arc at TQ. Well, this arc is also intercepted by the angle at S, so therefore those two angles are exactly the same. The measure of angle R equals the measure of angle S. So we can take the expressions that are there. 12x minus 13 equals 9x plus 2. And when we solve that for x, then we end up with x equals 5. So then we have to find the measure of angle R. Always go back up. So the measure of angle R equals 12 times 5 minus 13. So this equals 60 minus 13, which equals 47 degrees. So that's the measure of angle R. The next theorem is also an inscribed angle, but check out this inscribed angle. This inscribed angle intercepts this arc that's a semicircle. So this one, this is 180 degrees because it's a semicircle. So this has to be half of it, so that's 90 degrees. I also want you to remember that the sum of any angle of the acute angles in a right triangle, if I add on this triangle that I'm putting here to the side, the measure of angle A and the measure of angle B and this right angle have to add up to be 180. Well, we already know that there's 90 in here, so make the math easier for you. The measure of angle A plus the measure of angle B has to equal 90. So that's always true for these right triangles. Okay, so let's go to this one. So this is an inscribed angle that intercepts the diameter. The measure of the arc intercepted at the diameter is 180 degrees. So that means that that's a right triangle. So that means the sum of the acute angles in the right triangle is 90. So I can say x plus 4 equals 8x minus 4. Whoops. Hold on, gotta erase. So x plus 4 plus 8x minus 4 equals 90 degrees. In other words, the measure of angle A plus the measure of angle B equals 90. So I solve this, I get 9x equals 90. So x equals 10. Since we're asked to find the measure of angle B, the measure of angle B equals 8 times 10 minus 4, which equals 80 minus 4, which equals 76 degrees. Then we have this one where it's an inscribed quadrilateral. An inscribed quadrilateral has vertices, all of them on the circle. Turns out that opposite angles, again, opposite angles are across from each other in the quadrilateral, add up to be supplementary or 180 degrees. So for this example, I've got 14x in the u corner. I've got 8x plus 4 in the t corner. So 14x plus 8x plus 4 equals 180 degrees. When I solve this one, I get x equal to 8. So the measure of angle S, I don't even need that x for it because look, this is a 90 degrees here, so this has to be 90. So the measure of angle S equals 90, but I do need to use the x to find the other one. So the measure of angle T equals 8 times 8 plus 4, which equals 68 degrees. So this picture looks a little tricky, but it's not too bad if you just break it all down into little pieces. So first thing we're going to do is we're going to look, the AC is a diameter. So you see this angle that intercepts the arc that is a semicircle because it's on that diameter as well. So by the previous theorems, we know that this has to be 90 degrees right there. So we know that the measure of angle ABC is 90 degrees. Then we have to do the measure of angle BDE. So let's highlight again and look and see where that is. Here's BDE right there. The arc that it intercepts is arc BE. Arc BE is 96 degrees. So I go ahead and put that measurement right on the arc right there so I can see it. So that means that this angle right in here has to be half of that. So the measure of angle BDE is 96 divided by 2, which is 48 degrees. We can do a similar thing for the measure of angle CED. So CED intercepts this arc right here. CD, it says, is 68 degrees. So the measure of angle CED, that angle, is half of 68. Last of all, we have the measure of arc AD. So arc AD, I'm going to use the green to highlight this, goes from here all the way over to here. Well, if you notice, if I were to continue it on, if I add in arc CD, that would be a total of 180 degrees. How do I know that? Because there's our diameter. So the measure of arc AD equals 180 degrees minus 68, which is 180. 12 degrees. This one, do you see that diameter? So if you can find a diameter, I would always start there with the diameter and make sure you can find all those 90-degree things. So we're going to go and label this though. This is 7y plus 3 right here. This is 7y plus 3 right here. And then this one is 5y. Since angle 6 is an inscribed angle that intercepts the diameter also, we know this is 90 degrees and that's 90 degrees. So the sum of those acute angles in each of those triangles is going to be 90 degrees. So I can set that up for angle 4 and angle 5. The measure of angle 4 plus the measure of angle 5 has to equal 90 degrees. Well, if those have exactly the same thing in there, then I can say, you can write it this way, 2 of the 7y plus 3's equals 90 degrees. So 7y plus 3 has to equal 45 degrees. And you may have figured that out before without setting up that equation. If you did, that's awesome. So then when I solve that, I end up with y equal to 6. So the measure of angle 1 and the measure of angle 2 we know right now is 45 degrees each, because they have to be equal and they have to add up to be 90 degrees. The measure of angle 4 now, the measure of angle 4 and 5 go over there. So 45 here, 45 degrees right there. Okay, so the measure of angle 1, we just take that y that we figured out and we plug it in and you get 30 degrees. So the measure of angle 2 plus the measure of angle 1, because those are the acute angles again of a right triangle, they have to add up to be 90. We know the measure of angle 1 is 30. We just need the measure of angle 2. So the measure of angle 2 equals 60. All right, so this one, can you see what we need to do? You've got a quadrilateral inside inscribed. Every vertex is on the circle. So opposite angles have to be supplementary. So if that's 95 over here, then this has to be 85 degrees like that. The measure of arc TQR, though, you have to think a little bit more. T to Q to R, we have to use our inscribed angles on this. So you have to look at the angles. The whole arc that I just colored actually has an inscribed angle that intercepts the arc. There's just one, and it's 100 degrees. So the whole entire arc has to be 200 degrees. The reason why is because it's twice as big as the inscribed angle.